Will be able to graph equations by changing them to slope, intercept form. And using slope and y-intercept. Gives us we'll be able to graph equations by changing them to slope-intercept form and using slope and y-intercept. So essentially, yesterday we learned how to change equations into slope-intercept form. The day before, we learned how to graph equations that were in slope-intercept form by simply using slope and y-intercept. So that means today we are simply putting those two ideas together. So looking at this, we have 3y minus 3x is equal to 6. First thing that we want to do, we recognize this is not in slope-intercept form. This is actually in what form? Standard form. We'll go ahead and leave chain switch this, and we'll start solving for y. What inverse operation do I need to do to solve for y first? Paula. Not division. Oh, addition. Sorry, I was unclear. Adding what? Positive what? Positive 3x to both sides, because that's going to move that 3x to the other side of the equation and get it away for us. This is where Denzel gets confused, so let's just be clear what I'm doing here. I'm adding 3x to both sides. I'm just commuting the 3x to the front at the beginning, because that's where I want it to end up in slope-intercept form. All right? So that's going to give me 3y is equal to 3x plus 6. What is the next thing that I need to do, Cassandra? So I'm dividing by 3, and then... And so how does this division happen? Does it just happen to the 3x, or does it just happen to the 6? Marquita? Perfect. She says, trick question, Mr. Bucci. Do it to both. 3 over 3x plus 6 over 3. That gives me y equals 1x plus 2. Which means that in order to graph this equation, we know our slope is what? 1 over 1. And our y-intercept is 0, 2. So we go to our y-intercept 0, 2, making sure that's on the y-axis. Some people are putting these on x-axes, and that's getting confusing. Rise 1, run 1. Rise 1, run 1. That's 3 points. That's good enough to get a straight line. I'm going to go ahead and grab my trusty straight edge over here. Draw my line. Put my arrows on it to make sure that it is clear that this line goes on forever. There are an infinite number of solutions to this equation. And that's it. The alternative to doing this is picking 0 for x, 0 for y, and then plugging and chugging, and then graphing those 2 points, then picking another value for x, solving for y, I'm graphing that as a checkpoint. Marquita says that is doing too much. And I agree. This method to me is so much more efficient. However, if you have 21% mastery in your ability to change it to slope-intercept form, then perhaps you should stick to plug and chug, because I remember our mastery on that day was somewhere around 70%. So let's hope that our mastery today is better, because that means we can use a simpler process. All right, so let's look at this one. This is not in slope-intercept form. Y is not by itself. Cassandra, what do you think is the first thing we should do with this equation? Yeah. Even simpler. What's the next thing we should do, Ariel?
Add positive 2 to the other side.
So Ariel is asking me to add a positive 2 to both sides. Let's see what happens.
I'm wrong.
Ariel, why are you wrong? How do you know you're wrong?
Because Sam told me.
Well, what is our goal here? What are we trying to do? What are we solving for? Y. So when I did that step, did that get me closer to getting y alone?
No.
Okay. So what do we need to do then? Add a positive 3 to both sides. So let's see if that works. Gives me y equals 3x plus 1. Ariel, did that get me closer to getting y alone?
Yes.
In fact, not only did it get me closer, it got me all the way there. So we're now in slope-intercept form. Our slope for this equation is 3 over 1. And our y-intercept, Matthew, our y-intercept is 0, 1. So we come over to our y-axis, we find 0, 1, and our slope is 3 over 1. That means we rise 3, run 1, rise 3, run 1. Get that trusty straight edge out. And make sure we put our arrows on there, showing that we know this goes on forever, that every point on the line is part of this solution. And we move forward. Next problem. 3y plus 6x plus 3y equals 6x plus 3. Itzy, what is the first thing we need to do with this equation?
You have to put a 3 over 3y, so it cancels out, and you need to divide 6x by 3 and 3 by 3.
Yep, so we're distributing this division of 3. It's going to give me y is equal to 6 over 3x plus 3 over 3. Gives me y equals 2x plus 1. RJ, that tells me the slope of this equation is? 2 over 1. And the y-intercept of this equation is what, Marquita? 0, 1. So we come down to our point, 0, 1. We follow our slope, rise 2, run 1, rise 2, run 1. And then we graph our line, drawing the arrows straight through. All right, that's it. Key points for today. Key points for today. Psalm.
When we are trying to get y alone, we don't start by dividing immediately. We start with adding.
Okay, I think this is a common mistake for lots of people, so I think this is an important key point. Always start with additive inverses. Triana. Perfect. She's saying if given an equation not in slope-intercept form, solve for y to get slope-intercept form. Two other things that I will point out as just quick pointers. Number one, we've talked about this all along. Always double check at the end of your work, looking at your slope of your line, and make sure that if this slope is positive, you sloped a positively sloped line. Same thing here, if this slope is positive, I should be looking for a positively sloped line. Those are simple things that you can check at the end of every problem that are going to save you lots of trouble and save you lots of wrong answers. Are there any questions before you move on with your together time? Denzel.
So you just said that